Okay, so when you go under my assignments, and it might look a little bit different. For you guys. So let me go into the student mode here. And if you just go click on all assignments under MyMathLab, right at the bottom of that list, under chapter 7, you should see that I have two different versions of the practice final exam. So it has the same questions that the final exam has, but it shows you the different versions of the same problem, because if you'll remember, even in homework, you can have a couple different questions, kind of having you practice the same concept. So I keep all of those questions, in the practice final exam. And then, in the actual final exam itself, I'm obviously not going to have too many questions in there. So your practice final exam will definitely have a lot more questions in the actual final. And that's because, like I said, I show you all the different versions of it. So you can see there's, 64 questions in the practice, but I think 30 questions maybe at the maximum between both the part 1 and part 2 together. So I would definitely recommend you to look through the practice final exam, and the other one, the unpooled version. This one will actually show you each of the questions separately. So they're not going to be pooled together. So you will actually be able to see each of those questions. And remember, your practice final exam is not for a grade. This is just to let you see what the different types of questions are, and give you a chance to go through all of them and practice. So this one, the unpooled version, you will see definitely has 183 questions. And that's because I've just given you all the different options that you can see in the final exam. So if this seems like, this is going to be too many questions for you to look at, then you can always do the other version, just the practice final exam instead of the unpooled version. But this will give you the idea of what questions are going to be on the final exam itself. And then, as I was telling you, I've broken up your final exam into two different parts. First one is August 3rd, and then the second one is on August 10th. And that's actually what I wanted you to look at today is, some of these questions, and just kind of brainstorm in terms of how would you approach a question. If you see this on the final exam, how would you go about breaking this down? Because guys, remember, you're going to have 1 hour for each part of the final exam. So if you're going to be spending a lot of that time looking through your notes, or textbook, then you will be wasting a lot of time, because if you're trying to figure out, I know I remember doing this in the homework, but I just want to quickly look over how to do this, you're going to lose a lot of time, because I can only give you that 1 hour of class time. I may extend it a little bit more, but obviously we cannot be there for 2 or 3 hours taking a final exam. So I may allow you to stay a few minutes extra to finish the exam, but I've kind of designed these exams for 1 hour of our class time. So that way you want to practice, you want to be comfortable with these questions, because like I said, if you're going to be spending a lot of time looking for the solutions, you're not going to even get half of the exam done, because you will be losing a lot of that time. And so once you are done with your older homeworks, exams, whatever you guys are catching up on, you want to take at least 4 days or more, practicing, because you have that time. Officially we finished chapter 7 yesterday. Of course, I've given you the extension till Thursday if any of you were still, finishing up anything that was left behind and you needed that extra time. So remember, I've extended your exam deadline till Thursday. So any of you who were not able to get it done, you still have till Thursday to finish the chapter 7 exam. And then, of course, your final deadline is August 1st. So you do have time. We actually have, 2 weeks, almost 2 weeks, yeah, before we start taking our final exam. So use this time to practice. You don't have to do it all day every day, obviously, but take an hour each day and practice some of these questions. And the best thing I will tell you, the setting that I have done on these practice final exams, don't submit your exam. So how it says at the top here about submitting quiz, don't submit it if you're only doing partial, let's say 10 problems a day. Just X out of your window. So just close your window and don't submit it, because it will let you pick up where you left off. So that way, you're not having to spend 3 hours trying to get those 64 questions done, since you're just practicing this. You want to do 10 questions, 15 questions a day, do those questions, X out, don't submit it, wait till you finish all 64 questions before you submit your exam. And I would say do this 2 or 3 times to get a good sense, because all of these questions that you see in the practice can show up on the actual final exam, because the pool of the questions is the same. It's just I have selected, I think, like I said, 30 questions out of these. And, again, they can keep changing a little bit, because, they can have multiple different formats. And that's where this practice exam will really come in handy. So if you can practice this and feel comfortable with this exam, you have really good chance of doing well on the final exam. And remember, you can always go back through your gradebook. So gradebook at your end, click on gradebook, and you will see next to each assignment, it shows you that little review link. So if you click on review, it shows you which questions you got right, which questions you got wrong. So you can do those for quizzes, you can do those for chapter exams, and you can see, okay, I missed this question on my chapter exam, so maybe that's the one I want to practice a little bit on. Or maybe I got this question correct, but I don't remember what I did. So you may want to go back and look at those questions and see, okay, am I comfortable doing this? Because at the same time, all the questions that you did in your chapter exams, that's basically where my questions are coming from. So all the problems that you see on the final exam, you have either worked on them in homework, quiz, or the chapter exam. There are no new questions that you have not already seen in this course. So, take this time, practice. And I'm telling you, if you practice and get comfortable with these questions, there's just no way that you will not do well on the final exam. And what happens is, the more prepared you feel, the less nervous you will be on the day of the exam itself. So, if the more confident you are, like, oh, I got this, I know how to solve this problem, that nervousness will not be there on the day of the exam. So please, take these 2 weeks and practice. I know you've got other classes and other things you have to take care of. So, make a schedule for yourself, whatever helps you out to do your best in this class. Because, you guys have stayed with this class. We're in what, week 7 now? So for 7 weeks, you've worked hard, you've tried to do what you can. So just use this time to make sure you get the best result out of this class that you are hoping for. So what I want you guys to do is take a minute, read through this question, and then tell me. And when I ask you to send your answer, then. Don't send it just now. I just want you to read it for a minute. Get your answer ready. So all I want you to do is type your answer in the chat box, but don't send it, because I want everybody to get a chance to type their answers. And then when I ask you to, you can send the answer to this. So just have it ready. Do not send your answer in the chat box just yet. So basically, remember, this is coming from chapter 3, where we talked about translations and transformations. They are saying, write the function whose graph is the graph of y equals absolute value of x, but it is translated 8 units upward. So upward, of course, means we're doing vertical translation. Okay, if you have your answers ready, go ahead and send it. Alrighty. Let's see. So I've got Kayla, Sarah, Zach, Colton, Michael, Tiffany. Wonderful, exactly. So since we're talking about translating 8-unit upwards, remember the generic form of our transformations is, and I'm just putting this, in the general form, not specific to one function. You have A, then, we have the X minus H plus K. So the K value is what gives us the vertical translation. So that's always added at the end. So yeah, perfect. As you had Y equals absolute value of X plus 8 on the outside. So Hani, very nice. Let me see if I can get my absolute value box over here. And then outside of that, you do the plus 8. Perfect, very nice. Okay, this is coming from Drawing Good Graphs, which was also in chapter 3. So this is where we use the leading coefficient test. So this one is where they're talking about if you have this function, y equals, negative 4x to the third minus 10x squared, and they want to know, using the leading coefficient test, is your graph headed towards positive infinity or negative infinity for the y value, as the x value is headed to negative infinity. So remember, this was the one where we talked about, is your arm, for your graph opening up? Is it opening down? Is one of them opening up and the other one opening down, or, opening down here and opening up over here? So those are the 4 scenarios. So, what happens in this one on the top left, this one says as x goes to positive infinity, y also goes to positive infinity. And this one says as x goes to negative infinity, y still goes to positive infinity. So that's this guy. This one here will be, basically doesn't matter if x is going to positive or x is going to negative infinity, your y is always going towards negative infinity. And then, of course, it changes over here. This one will say as x goes to negative infinity, y goes to positive infinity. And this one will say as x goes to positive, y goes to negative, and this one will change. X is going to negative, y goes to negative, x is going to positive, y goes to positive. So what kind of behavior will this function have over here? So which option would you choose? So again, have your answer ready, and you can just type, INF or negative INF when you put your answer in the box. So just have your answer ready, and when I ask you to, you can send me the answer. So y is going to positive or negative infinity. Okay, go ahead and send your answer. Okay, so looks like I saw positive infinity and maybe one of them was negative. Okay, so I've got Kayla going to positive infinity, Suhani negative, Colton positive, Michael positive, Sarah positive, Elias positive, and Zach is also positive infinity. All righty. So one thing, and if you guys have seen the video lecture for this, you will know I talk about this. And that is, if you can remember what the function y equals x squared does, We know that's a positive parabola opening up. So that helps you remember that no matter where the x is going, y is always going to positive infinity. With the two arms down, you can basically think of that as negative, x squared being your function. So this is where, again, x goes to positive or negative, but y always goes to negative infinity. The bottom right function is actually your y equals x to the third power. And then the other one is y equals negative x to the third. And that's exactly what we have over here. You have a negative x to the third power, because remember, for the leading coefficient test, you need to know if your leading coefficient is positive or negative. And then do you have an even or an odd exponent on your leading coefficient? So as you will see with this positive x squared, this is basically positive and an even exponent. The negative x squared is of course going to be negative and an even exponent. With the positive x to the third, this guy is of course positive and odd. And then this guy here will be negative and odd. So that's the behavior you are looking at. So yeah, very nice. As x goes to negative infinity, your y is going to positive infinity, because that's this arm of your graph that we are looking at. So this guy is going to be positive infinity. And when in doubt, honestly, you guys can use a graphing calculator, because the leading coefficient test is basically wanting to know what the arms of your graph are going to do. Alrighty, so let me clear this out over here. Okay, so this one honestly can be a question coming from chapter 1, because I think it was section 1.7 where we talked about this, or it could also be coming from chapter 7, because obviously that's where we talked about the conic sections, and we discussed circles in conic sections also. So either way, it's going to be the same way that you solve these type of problems. So can you tell me what we would need to do? Just kind of walk me through the process of how would we find the center and radius for this circle here.
So you'd start by moving the constant and then completing the square, or at least that's how I do it.
Yeah, very nice, Sohani. So yeah, let's start by moving the 24, the constant term, to the other side. And then Sohani, on what part are you completing the square? For both x and y, or just one of them?
I started by doing it for y, and then yeah,
Okay.
just for y.
So what happens, remember guys, when we are completing the square, you need to have the leading term and the middle term, right? So that means you have to have the y square and the y term. If we were going to do completing the square on the x term, we would need the x square and the x, but of course you will see we only have the x squared term, right? We don't have that middle term with just the x on it. So that means we are actually not going to be completing the square on the x squared term. We're just going to be completing the square for the y terms. So we've got y squared plus 2y. Now remember, when we are completing the square, you take the coefficient of your middle term, you divide it by 2, and then we square that so that we can come up with our third constant term. So we take the coefficient of the middle term, which is 2, this guy over here, and of course we take its half, so 2 divided by 2, and then you square the whole thing. So 2 divided by 2 is 1. 1 squared, of course, is going to be 1. So completing the square basically means you're changing it into a perfect square trinomial, and that's what happens when you bring this 1 into that, you know, terminology or this expression over here. So this is the completing the square part. This is the number that we needed. So now we can come back to our equation for the circle over here. So these are the terms that we already have. For completing the square, we are adding 1. So remember, we always want to maintain that balance of our equation. So you add that 1 to both sides of your equation. And then, of course, we will need to factor this and we will need to add these. Like I said, x squared, there's not a whole lot we can do with it. So we just leave that as x squared. Go ahead and tell me what this will factor into for your y squared plus 2y plus 1. And then right-hand side, 24 plus 1 will become 25.
It's going to be y plus 1 squared.
Very nice. Yeah. So with factoring, basically, you are looking for two numbers that will multiply to give you 1, but add up to give you 2. And that's how you factor this. So multiply to give you 1, but they will add up to 2, which of course is going to be 1 times 1. So you can factor this into y plus 1 and y plus 1. And since you did completing the square, remember I said this comes out to be a perfect square trinomial. So that means both your factors are going to be the exact same factor. So that's why you get y plus 1 and y plus 1, or as Suhani said, y plus 1 to the second power. So this is actually the equation of our circle. Remember, the standard form is x minus 8 squared plus y minus k squared equals r squared, where the center is going to be those hk values, and the radius is of course going to be, just r by itself, not r squared. So can you tell me, looking at the equation, what our center and radius are going to be for this circle?
The radius will be 5 and the center will be 0, (-1).
Very nice. Yeah, so remember, you take the square root of that 25 on the other side to get the radius. So that's where the 5 comes from. So taking the square root of the constant term. And then remember, those h and k values give you the center. So since you have y plus 1, technically that means you have y minus -1. So the number itself is going to be -1. And since you have only x squared over here, that means nothing is being added or subtracted from the x. And so that means that number is actually going to be 0. Because another thing that might help you to kind of remember is, when you look at the equation of a circle that is centered at 0, 0, your, x and y are just by itself. So you have x squared and y squared. So again, having that x squared automatically tells you your x value is at 0. It hasn't moved, but the y, of course, has moved to -1. So like I said, you can go back to chapter 1, or you can go to chapter 7 to find, similar examples to this one. So this guy will be 0 and -1. This guy will be a radius of 5. Okay, this one is coming from chapter 2 when we first introduced functions, because remember, this is where instead of just using y equals mx plus b, we introduced the notation of f of x equals mx plus b, or whatever the equation might be. This is a second degree polynomial. So when they ask you to find g of p plus 3, what exactly do you need to do here?
You have to substitute the p plus 3 wherever there's an x.
Very nice, Tiffany. All righty. So yeah, wherever there is an x, you are substituting it with p plus 3, because they're basically saying you have g of x as your function, and instead of x, they're asking you to use p plus 3. So what that means in your original equation, and let's clear this out here, you are looking at 2 times x squared, so that's 2 times x squared plus 2 times x plus 2. So I just usually set this up with, the blank spaces. And then when I'm ready to substitute for the x, I will just go ahead and plug in our p plus 3 in here. So to simplify this, where do you think your first step needs to be? To try and, break down that right-hand side.
You follow the exponent, so don't you square the p plus 3 first?
Very nice, Tiffany. Yeah. So before you can distribute that 2 inside the parentheses on that first part, we actually need to take care of the exponent first. Again, following, please excuse my dear Aunt Sally. So exponent before multiplication. So that's what we need to do here first, is go ahead and FOIL, as Tiffany mentioned, and then we can bring in that 2 times inside of it. So I'm actually going to do this on the side, the FOIL part. So we've got p plus 3 to the second power, which of course is p plus 3 multiplied into itself twice. And then remember, with FOIL, you do the first terms, the outer terms, the inside, and then the last terms. So what will that end up giving us here, guys, when you complete the FOIL?
It's gonna give you p squared plus 6p plus 9p.
Yeah, very good. 3 plus 3 will give us 6, so 6p. 3 times 3 will give us 9, so that's going to become your constant term, p squared plus 6p plus 9. So bringing that in here, you still have that 2 in the front, but with the FOIL. And now, of course, we are ready to distribute the 2 inside the parentheses. And of course, we'll do the same thing here in the middle term. Go ahead and distribute that. So this will end up giving us 2 times p squared, 2 times 6, p, of course, and then 2 times 9. And then once you come to the middle term, same thing, 2 times p, 2 times 3, which will give us a 6, and then that plus 2 at the end. And then, of course, all you are doing is combining your like terms. So again, I'll give you a second or a couple more to just go ahead and finish adding that up. And again, have your answers ready. And when I ask you to, you can send it through the chat. So again, don't send it now. Just type and have your answers ready. Okay, go ahead and send me your answers. All right, let's see. So I've got Zach, 2p squared, 14p plus 26. Tiffany looks like the same thing. Elias. Okay, Michael, you've got 2p squared, 14p plus 29. Sarah, you have 2p, 14, 26. Okay, Colton, same thing. Kayla. Okay, so it looks like 26 seems to be what that last number is. And Michael, you had 29 in yours. So 2p squared, of course, there's only one single term. So of course that guy will stay the same. For the middle term, the p term, you've of course got 12p and 2p, which will add up to 14p. So far, so good. And then the last one was 18 plus 2 will give you 20, 20 plus 6 will give you 26. So Michael, looks like you just ended up making a little bit of error on that last term, but otherwise, obviously you were on the right track. So yeah, that's all you really have to do. And that first part is really the main part, is remembering to FOIL the parentheses first and then distribute your constant term on the outside. And then, of course, you bring in the rest of the terms and simplify it from there. So let's go ahead, put this answer in. We've got 2p squared. Let's see, plus 14p plus 26. All righty. All right, getting into solving the system algebraically. So, of course, remember this is coming from chapter 5, basically 5.3, because that is where we had talked about solving systems of equations. Remember 5.2 is where we did the ones with the 3 variables and 3 equations or 2 equations, and then 5.3 is where we got into the nonlinear system. So the first thing they want us to do is solve this algebraically, and then of course we'll graph that to verify our answer. So any ideas, if you're solving this algebraically, how are you going to solve this system?
You can set them equal to each other.
Yeah, since you have them set up as y equals 3x squared and y equals 2x, you can go ahead and set them equal to each other. So that would give us, basically that's the substitution method. So 3x squared equals 2x. Okay, and then where would we go from here next? Because the goal is to try and find x by itself, right? To get the x's by itself.
So can you move the 2x over to the other side?
Very nice. Yes, Kayla, very good. Let's go ahead and subtract that guy, move it to the other side. All righty. And then what do you think we should do next?
You could try to complete the square.
No, I've never tried completing the square on this one. I'm not entirely sure where that will lead us. What else we could try? We can try the completing the square, but I wanted to see if anybody had a different take before we did that.
You could take x out of both of the variables.
Yeah, that's kind of what I was thinking about, is factoring out, what's common between the two terms. I will actually try completing the square on the side, but just to show you, the easier one would be, to go ahead and you can see between 3x squared and 2x, x is going to be a common factor. So you can bring that 1x outside, which will leave us behind with 3x in the first term, because out of the 2x's, obviously one of them goes outside, one stays inside. Minus from the second term, we've already taken the x outside, so you're just left behind with the 2. And then at this point, you would take each one of your factors, set it equal to 0. And so, of course, you're getting x equals 0 as one of those answers. And then this one will end up basically just giving you x equals 2/3. So once you find your x values, you have to basically go back and find your y value. So you will need to do this for both of them. So again, have your answers ready. I'll give you a couple minutes to work on this. Let me see what your y values are coming out to be for each one of these x values. So what will those ordered pairs look like? So again, just have your answer ready. And when I ask you to, you can send it through chat. You know, Suhani, I believe your completing the square will work on this. It should give you the same answers. Okay, if you guys are ready, go ahead and send me your ordered pairs. All right, 0, 0, 2/3, 4/3, 0, 0, 2/3, 4/3, okay. So let's see, I've got Kayla, Colton, Elias, Sarah, Zach, Suhani. Alrighty. So yeah, since we know that our equations are, you know, y equals 3x squared or y equals 2x, you can use any one of them or both of them if you wanted to check. So if your x equals 0, then, you know, of course, your y equals 2 times 0, which would, of course, just end up giving you 0. So that's where your ordered pair 0, 0 comes from. If you are doing y equals, let's see, what was our x value over here? 2/3. You can do, again, if I use the same equation, 2 times x would be 2/3. So you can see this one will, of course, multiply on the top. 2 times 2 is 4. Denominator will stay as 4/3. So that's where the 2/3 and the 4/3 ordered pair is coming from. So let's go ahead and put those ordered pairs in here. So that's 0, 0, comma, and then our 2/3 and 4/3. Okay, let's clear this out and see what the graphs for these guys will end up looking like. Okay, so of course your 3x squared is going to be a parabola. Now we know one of those ordered pairs is going to be 0, 0 because, you know, obviously that point is a point on both our graphs. Now, what other points can I use to graph my 3x squared function? Because we need 2 more points to graph that.
You can use 1 and -1.
1 and -1, okay. For our x value, you can use 1 and -1. So of course, 3 times +1 will of course give you 3. If you did 3 times -1, that's going to be -1 squared for your x value, which will automatically make it positive again. So 3 times +1 will of course give you +3. So very nice. So your ordered pairs are actually going to be +1 and +3 and -1 and +3. On the same graph, you're going to be graphing y equals 2x. So that's going to be a straight line. Again, we know the point 0, 0 is going to be one of the points on the line. And since this is, you know, y equals 2x, basically, same thing you can do over here. You've got the 0, 0, and you can use 1, -1 again. 2 times +1 is 2. 2 times -1 is going to be, excuse me, -2. So that will give us the ordered pair of +1, +2, and that you can see automatically gives you -1, -2 over here. And just to go in, you know, zoom in a little bit, you should be able to verify that, you know, we definitely have the ordered pair 0, 0 where the 2 graphs are intersecting. And then this other point where, you know, again, the parabola and the line are intersecting will of course be where our 2/3 and 4/3 ordered pair was going to be. Okay, and then just save that. Oh, I don't believe I did that. Okay, very quickly. 0, 0, 1 and +3, 1 and -1 and +3. We have 0, 0, 1 and 2. There we go. Okay, this one is, I believe it's chapter 3, where we talked about operations of functions. And as you can see in this one, we are talking about dividing our f of x and g of x function, and they want to know basically what that equation will look like, and then what will the domain for that function end up looking like. So let's start with what the function itself looks like. So you've got your f of x and g of x over here. They're of course asking us to find the function of g divided by f. So remember, just as definition, that means you take the g of x function divided by the f of x. So again, I'll just give you a minute to get your answers typed into the chat box, and don't send it till I ask you to. And let's see what the equation looks like. And then, you can do a space or something, and then next to it, write down what do you think the domain of this function should be. So take a minute, look at it, type your answer, and when I ask you to, you can send it through. Okay, go ahead and send your answers in. Okay. So I've got, let me see. We've got Kayla, Suhani, and Michael. Sarah, Tiffany, Holden, okay. And all of you looks like have x -1 on the top, square root of x on the bottom, Zach, Ilias. Yeah, very nice. And now again, I'll give you another, couple, well, hopefully it shouldn't take you too long, but take a minute and let's see what your domain for this function comes out to be. Because, remember when you're working with functions like these, where you have your variable in the denominator, you have to think about, because, always with variables being in the denominator, remember we have to think about what values are going to make my denominator 0. Of course, square roots have their own restrictions. So you kind of have to think about, okay, so I have a square root and my x is in the denominator. So how is that going to affect what numbers I can use for that x value? And that's what's going to create, what the domain of this function has to be. Because no matter what, division by 0 is always going to be undefined. So we definitely cannot have a 0 in the denominator. And then what happens with that square root symbol being in the denominator also? Okay, go ahead and send your answers in, guys. Alrighty, I've got 0 to infinity coming from Tiffany, and that's not including 0. Colton, you've got 0 to infinity, not including 0. Elias, you're including 0 to infinity. Zachariah, not including 0 to infinity. Sarah going from 0, not including 0 to positive infinity. Kayla, x has to be greater than 0, so 0 to infinity, not including 0. Michael, you've got including 0 to infinity. And Suhani, you've got 0 to infinity, not including 0. So looks like you guys have the same values. It's just a difference of some of you are including 0 and some of you are not including 0. Alrighty, so let's take a look at that. So since we have the square root of x in the denominator, we know your square root cannot be, negative number, because once you start looking at negative numbers, you get into imaginary. So we know in general, the square root of x itself either has to be equal to or greater than 0, and that's just the square root of x by itself. However, since your square root of x is in the denominator, you cannot include 0, because if you include 0, that means you are saying I can have square root of 0 on the bottom, which, of course, will come out to be 0. And we cannot have 0 in the denominator. So that's why you're not including 0. It's just greater than 0. I think somebody mentioned that in their answer. Kayla, you had that x has to be greater than 0. Yeah, so very nice. That means we can go from 0 to positive infinity. We just cannot include 0. It's got to be parentheses. So remember, brackets means you are including, parentheses means you are not including 0. And so that's a big difference that you kind of have to think about, because of that square root, we are not including 0. If it was just x by itself, we could not include 0, again, because we don't want division by 0. And guys, keep in mind, domain and range questions will definitely show up in, of course, your final exam. So that will be something you definitely want to feel comfortable with. This one, as you can see, is coming from chapter 7, where we talked about conic sections again. And of course, you can see this one here is discussing hyperbola. So does anybody remember looking at the equation? Is it supposed to open up and down or left and right? Y squared over 4 minus x squared over 64 equals 1. Because with hyperbolas, do you tell by which variable is first, or do you tell by which one has the larger denominator? First, there's the ellipse, and there's the hyperbola. Oh, come on, guys. You just did this week.
Opens up, down.
Very nice, Michael, because your y square is the first variable. So this one actually opens up and down. So that automatically means anything that's opening, left and right is, obviously out of the picture. So you are honestly just choosing between the two middle graphs, B and C. And then, of course, you kind of have to see, well, which one is it going to be? So this is what graph B looks like. And this is what your graph C looks like. Anybody want to take a guess at which one it should be? Because again, remember, and let me make this guy a little bit bigger. What does this number underneath the y square tell you?
It tells you the min or the max.
Say that again? The minimum or the maximum? That actually happens more in the parabola. This one will actually give you where it crosses the y-axis, right? Because it's going to give you the y-intercept. Now the question is the y-intercept going to be 4 or something else? Because if you look at this scale over here on this graph, you can see they're showing you 13 over there, but that's the halfway mark. So this is actually broken down into 2s. So this is actually at 8. And then let's look at the other one. If you look at this guy, again, this is broken down into 2. So this is actually at 2. So you have 2 and 8 where your y-intercepts are. So how does that help us? So what do you think your intercept should be? Okay, Kayla, no problem. I will see you next week. Take care. Remember, guys, these numbers are a square and b square, which means you are looking at a and b. So that's got to be the square root of 4. So if it's got to be square root of 4, that means your y-intercept is going to be at 2. And if your y-intercept is going to be at 2, that means this is the graph you are looking at, because that's where it's, crossing the y-axis at, is at, +2. And then, of course, this guy here would be -2. So that's what you need to be looking at when you are, working through these examples. That would be the easiest thing. And then, of course, you can do those fundamental rectangles that you can see here, and you can try to figure out where those ordered pairs will be. That would be the other way of going about doing this. Now, for your foci, remember you have to do the calculation for these guys, and that is that relationship between A, B, and C values. So your A and B are going to be coming from the denominator, and then you have to calculate the C to come up with what the foci is going to be. And obviously, since this is a hyperbola that's opening, up and down, remember the ordered pairs of your foci have to be on the y-axis, which means it's going to be 0 and +C and 0 and -C, once you calculate this number. So can you tell me what our C value should come out to be when you do the little equation here, a square plus b square equals c square? And it doesn't look like it's going to be an integer or whole number, because I think, because when you're adding, 64 plus 4, that's going to add up to 68. Which is not a perfect square number. So when you end up taking that square root, you have to simplify square root of 68. And you can see in the instructions, they are asking you for radicals. So no decimal answers. So anybody know what that square root of 68 will simplify into?
2 to the square root of 17.
Yeah, very nice. Very good. So 68 can actually be broken down into 4 times 17. Square root of 4 will come outside as 2. And, of course, 17 doesn't break down. So that continues to stay inside the radical. So when you type in your ordered pairs, like I said, since these are points on the y-axis, you will have 0, 2 square root of 17 as the first ordered pair. And I'm basically just going to copy this and just put a negative sign in front of the 2 square root of 17. And the very last part is they're asking you for the equations for the asymptotes. So remember, those are the equations in the form of a over bx or y equals b over ax, of course, with positive and negative signs. Which one of these is it going to be for a hyperbola that opens up and down? Is it a over b or is it b over a? Because, again, those will be the things you will need to remember if you see these questions show up on the exam, because one of them is for opening left and right, and one of them is for opening up and down. So is it going to be in the form of a over b, which would, of course, be, your a value is 2, b value is 8, or is it going to be, 8 over 2, which, of course, then you can simplify into 4, or this guy into 1/4.
A over b.
A over b, yeah, for hyperbolas opening up and down. So you're actually just putting in y over here in that first box. This is going to be plus or minus a over b, which is 2/8, or simplify that fraction into 1/4. And remember, this is going to be an equation, so it's 1/4 x. Don't forget that x variable there. And so, of course, I'm going to submit the quiz so we can see how we did on these. And, of course, we haven't gotten everything done. So, our first 7 questions that we did okay on them. So that's why I was kind of hoping that, to show you, do that critical thinking, look through and think about, okay, how do I need to solve this question? If you can remember what section it's coming from, you can use that section to go back and do a reference, because, it might have been a while since you've done some of those first chapters. So take your time. Like I said, don't submit your quiz, just X out, so that way you get a chance to work on all 64 questions, and then you can, go through it a lot more quickly once you feel confident in that. So again, guys, let me know if you have any questions. Those of you who are still finishing your older assignments, email me to get your passwords if you haven't done that. And then I'm here available through email, or if you want to meet and ask for additional help, okay? All right, guys, if you don't have any other questions, I will see you next week. Be careful. Stay safe and have a wonderful week, guys. Be careful. Bye, everyone. Take care.
I'll probably need, I didn't get to